Good morning, students. Today we are discuss about the Poisson's equation. Okay, last class we have discussed Stokes law. That same that principle we have to use in here also. Poisson has analyzed the steady flow of liquid through a capillary tube. Okay, he derived an expression for the volume of the liquid flowing per second through the capillary tube. First, we are taking to the one capillary tube and whatever it is, we are taking the liquid and through flow of the through the capillary tube. Okay, so next he derived and the expression for the volume of the liquid. Volume of the liquid flowing through the capillary tube per second watt. Okay, wow. So as per the theory, the following condition must be retained. Okay, while they derived the equation, what are that? You see that the flow of liquid through the tube is a streamlined. What happened? It's a streamline. The tube is a horizontal, so that the gravity does not influence the flow. The horizontal, the tube is horizontal, so the gravity does not influence the flow. The layer in contact with the wall of the tube at the rest. Okay, the pressure is a uniform over any cross section of the tube. So next you see we can derive the Poisson's law equation using the dimensional analysis. So now we are using the Poisson's derivation using the dimensional analysis. Consider the liquid flowing steadily through the horizontal capillary tube. Let V, the small v equivalent taking the capital V by T. So capital V, it's a volume. It's at a time. Be the volume of the liquid flowing as the per second through the capillary tube. It's a depend on what are the depending means coefficient of the viscosity eta of the liquid, the radius of the tube R, and the pressure gradient P by L. Okay, wow. Pressure L. Okay, so now we are considering to the Poisson's law equation. V directly proportional to the eta A R B P by L power of C. So we are taking to that we are applied to that one constant value means V equal to K eta A R B P by L power of C. K is a dimensional constant. So we have to explain through the dimensional analysis. Okay, wow. So now we see that V modulus of V equal to volume of time. So volume would have value and time would have dimensional form of L cube T power of minus 1. So d by dx next. Okay, wow. So the pressure by distance. So pressure value m L power of minus 1. You see I written that pencil. M T L power of minus 1 T power of minus 2 divided by L. Okay, this L you are going to the upside means what happened? L power of minus 1. Already they are having the L power of minus 1. Okay, wow. You see the L power. This L you are going to up means L power of minus 1. Already you are having to the L power of minus. So M L power of minus 1 again L power of minus added means minus 2. M L power of minus 2 T power of minus 2. You see here. Okay, so next eta equal to M L power of minus 1 T power of minus 1 R equal to L. Okay, now we are applying to the formula. Which formula we are applying? So this formula we are applying. Okay, when the formula dimensional analysis formula, so we have to apply. So apply பண்ணீங்கன்னா L cube T power of minus 1 equal to M L power of minus 1 T power of minus 1. அதனுடைய formula what? A. So next L B. So the P by L power of C la M L power of minus 2 T power of minus 2 C. Okay, so we are applied to that the basis line we are added means this equation come. So next, so the equation power of the M, L, T and the both side we get. So இங்கே எம்மோட வேல்யூ கோஃபிஷியன்ட் மட்டும் எடுக்கணும் இந்த எம்மோட வேல்யூ. ஸோ இங்கே எம்மோட வேல்யூ என்ன இருக்குது a plus c. அப்போ இங்கே m வேல்யூ பவர் லைன் இருக்குது 0. ஸோ we are taking to 0. ஸோ நெக்ஸ்ட் எல்லோட வேல்யூ மைனஸ் a ப்ளஸ் b மைனஸ் 2c இருக்குது. ஸோ இதனுடைய வேல்யூ ஹியர் l பவர் ஆஃப் 3. ஸோ we are taking to the 3. அடுத்து டீயோடைய கோஃபிஷியன்ட் we want to equalized. ஸோ பார்க்கணுன்னா டீயோட வேல்யூவு டீயோட வேல்யூவு மைனஸ் a மைனஸ் 2c. ஸோ இங்கே டீயோட வேல்யூ ஈக்குவல் டு மைனஸ் 1. Now we are applying to that a equal to minus 1, b equal to 4. So a and c equal to verify that. இங்கே இதை வந்து நீங்கள் you see that algebraic equationsல போட்டுனா we have to get the value a equal to minus 1, b equal to 4, c equal to 1. We are get the value. That value we are applying to that this formula. இந்த formula apply பண்ணணும். Okay, sorry. This formula we are applying to that first formula we are find out to know v equal to k eta formula. That formula you are applying that values. So finally we are giving to the constant value means we are get to the values. We are find out the value k oda value pi by 18 we are taking means so value the pi r power of 4 p by 8 eta l. This is the viscosity. This is the Poisson's equation. This is the Poisson equation. Above that Poisson equation for the flow of liquid through a narrow tube or capillary tube, this relation holds good for the fluids whose the velocities are the lesser than the critical velocity. The velocity lesser than critical velocity. Okay, so next you see that application of the viscosity. So you see that some the 4 given. You see first one, the oil used the lubricant for heavy machinery parts should have a high viscous coefficient. So we are using that the factories having some of the machinery, heavy machinery, that machinery we are to using the some of the lubricant oil. That oil you are using means that machine is run is properly smoothly it's running. Okay, that oil also we are using to that our heavy vehicles also. So next you see that the highly viscosity liquid used to the damp the motion of the some instrument and it's used as the brake oil in the hydraulic brakes. So the hydraulic brakes where we are using that the some big machinery, that is example of the JPC also we are using that it's a braking of that motions. Okay, so next you see the blood circulation. Our body also using this one. The blood circulation through the arteries and the veins depend upon the viscosity of the fluids. Okay, the Milligan experiment you have to study will be 12th standard. The Milligan conducted the oil drops experiment to determine the charge of the electrons. He used the knowledge of the viscosity to determine the change. Okay, wow. So next you see that next topic is surface tension. I hope you are understood that Poisson's equation and application. So next you see that intermolecular forces. So different liquids do not mix together due to the physical properties such as the density and surface tension force. Example, you see that you take a kerosene and oil. Kerosene oil and water. Water you are added means it's not added. Okay, wow. The water up having to that kerosene, but it's not mixed together. Okay, wow. Okay, so that the mercury does not wet the glass, but the water sticks to the glass, right? Mercury, we are using the mercury, where we are using the mercury, the temperature, thermometer having the mercury, whenever the heat means the mercury is flowing to the glass tube. Okay, wow. But it is not stick to that glass wall. Okay, so next water, you take the water is stick in the wall. Okay, wow. So now you see that the mostly related the free surface of the liquid. The liquids have no defined shape but have the definite volume. This and all you are studying that lower class only, you know that very well, right? Hence they occur the free surface when the poured into the container. So liquid is not having a definite shape, but whatever you are taking vessels, that shape only we are telling, right? So it is also the surface only. It's a depend on the surface only. Therefore the surface has the some additional energy called as the surface energy. So that surface having to energy, some additional energy, that is we are called the surface energy. The surface has some additional energy called the surface energy. The phenomenon behind the above fact is called the surface tension. Laplace and Gauss developed the theory of the surface and motion of the liquid under the variation situations. You see next one, the molecule of the liquid are not rigidly fixed like the solid. You see that molecules, liquid molecules, solid molecules, it is not a same, it is a different. Solid molecules here compressly it's a fixed, but a liquid is a freely having, okay. Liquid molecules is a freely having. You see that the force between the molecules hold the liquid together is called the Coenzyme Force. It's a very important, underline this word. Coenzyme Force means the force between the molecules hold the liquid together. Okay, wow. So what happened? The liquid la the two molecules the force apply பண்ணும்போது it's a holding together. It's a that force we are telling the Coenzyme Force. When the liquid is a contact with a solid, the solid the liquid it contact the solid, the molecules of this solid and liquid will exposed the attractive force. So what happened? The liquid and the solids attract to the force. Okay, it's attractive the force. This is called the adhesive force. Okay, it's important, underline. The molecular force are effectively when the effectively only when the distance between the molecules very small. The molecules, the liquid or water you are taking to that, the molecules one molecules to another molecules, the distance is very small, about that 10 to the power of 9 meter irunda. Okay va, the distance through which the influence of this molecular force can be felt in the all direction constitute the range and is called the sphere of the influence. So what happened? The solid and solid molecules and liquid molecules, in between the gap it's a 10 to the power of minus 9 is all the directions applied to that influence, all directions applied to the force. Okay va? So this is called the influence force. The force outside the range or the rather negligible. The outside of the force is the negligible. So consider to the three different molecules. Okay va? Three different molecules in a given liquid la podunga. A first is A, second one B, third one C. You are denoted the names. Then you have to put in flow throw to the liquids. First you see that let a molecule A, molecule A, you are taking to the one molecule of the object, or take to one object. Molecule A is considered well inside the liquid. It's going to the deeply going to that liquid within the sphere of the influence. It's a sphere of the influence force. Why we are telling means that the sphere is moving to, deep in the water. It is all the directions. It's all the surface, all the solid surface, all the direction leave it to that force. Okay, it's applying the force. Since the molecule interact with all other molecules in the all direction, so what happens? It's the liquid, the solid molecules and liquid molecules interact with all the directions. Okay va? The net force experienced by a 0. So the net force what means is a 0 only. Now the consider of the molecule B, which there is a 3/4 lies below the liquid. 3/4 முக்காவாசி என்ன இது மூழ்கி இருக்கு, half of கால்வாசி மட்டும் என்ன இருக்கு மிதக்குது. ஓகேவா? So in the air, though 3/4 is deep in the soil, one fourth is in the air. Okay, the air irukku. So that what happened that since the B has the more molecule towards the lower side then upper side வரை compare பண்ணால் the more lower side in the upper side. So what happened, the gravitation, the surface tension force more applied in the downwards only. Okay, the C also you see that chosen the liquid surface, the upper half in the air, lower half in the liquid. So what happened, the C la lower side வந்து half of one fourth only it's here deep in the water, other 3 parts is here air in the water. What happened, it's the surface tension is here small quantity only, it's here that part, the small quantity part only it's here interact with the water molecules, so it's all the directions only, but others in that air only, but the surface tension force is applying on the downwards only, it's pulled in the surface space. Okay, so this is the so next you see that when any molecules brought towards the surface from the interior of the liquid, so work is done. So interactive, that molecules interact the what surface tension means the work is done. That work is we are telling to that potential energy, the work is stored in a potential energy in the molecules. So the molecules on the surface will have the greater potential energy than that of the molecules interior of the liquid, but for the system for the system to be the under stable equilibrium, so the system is under stable in the equilibrium, so it is the potential energy must be the minimum. So minimum of the potential energy in the solid means the surface tension also that is stable. Okay, so next you see that example for the surface tension, the water bugs and water stickers walk on the surface of the water. The water molecules are pulled inwards the surface of the water, act like the spraying or stretched membranes. What happened, that water bugs, some of the insects, the two insects you see that water bugs and water strider, so walk on the water means that the legs, it's a pull, the water is a pulled that surface of the water. Okay, but that surface of the water, the surface tension leaving the sum of the force is equal to the insect of the weight, equal to the insect of the weight, insect உடைய weight இங்க surface tension pull பண்ற அந்த weight என்னது ஈக்குவலா இருக்கு, so it's easily enabled to walk on the water surface. Okay, so next you see the brush. You take 1 cup of water and you put in the paint brush. What happened, that all the water it's interact with the brush and the brush உடைய needles la, but what happened that it's a heavy, it's அப்படியே பிரிஞ்சு இருக்கிற மாதிரி இருக்கும், it's a that in a waterproof. After you remove out of the water the brush, the brush you take out of the water means what happened, all the air is here joined together, this is the surface, all the water surface is a very very less. Okay, so next you see that another one, this experiment you see, it's a very interesting one, sir. So now you are taking to that the plastic papers. Okay, the plastic papers you are take and cut it to the shape like to the boat, so the front edge is very sharp, so back side is here some of not touched means the cut பண்ணிருக்கணும் ஒரு line, you see that diagram the cut, so that near you are keep it one compour means karpuram, the compour one you are keep it, and like slowly you are in the water, what happened, flow to the water, it's a moving, so when the compour dissolve in the when the compour is dissolved, that times what happened, the boat is here moving to the forward. Why means the surface tension is here flow to the backward side. water backward side. The surface is the backward side, so moving, pushing to the backward side. So the boat is here moving to the forward. Okay, so this is only. Okay children, I hope you are understood. Thank you children. Next class we see.